News. This is Scott from the Nibiru channel. I have our physicist with us today, and also we have Chris Potter live here on Planet X News. Chris and the doctor, how are you doing today?
I'm very well, thank you, Scott. And how are you?
I'm doing pretty good. I'm going to keep a little quiet so everyone can hear you speak because they love your voice and your accent.
Oh, thank you.
And today we're gonna take a look at some more footage, ladies and gentlemen. We were going to be bringing up some more of the SDO footage, and we were going to be taking a look at our sun. But unfortunately, the powers that be do not want us to show you what is currently happening on the sun. As we were trying to get the live stream going, we were not able to link up with the SDO website, which is naturally controlled by NASA and the government. And all of a sudden, the site is down. It almost looks like it has disappeared. So they are probably doctoring some images. They probably have their paint by numbers, little watercolors out with their little paintbrushes, and they are probably doctoring images up as we speak. Now, we've been trying for the last hour to get onto the site so we can bring you this imaging, but they will not let us. And we were going to be reviewing a report that the doctor had submitted to both me and Chris about less than a week ago. And the report was pertaining to why does the sun have so many coronal holes on it. So we're going to be bringing up that report. It's on a PDF file, and we did a report on this a few days ago, and we're going to go ahead and bring this up so everyone can see it. So, Doctor, how are you? How's everything going where you live?
Yes, I'm well, thank you. Well, yeah, I just have a lot of lecturing to do sometimes, and I'm being busy. But I'm ready to talk to you and
okay, we're going to go ahead
about what I've written in that article.
Does everybody see my screen?
Yes, sir. So I wanted to pose a question to the doctor. What is your understanding of what a coronal hole is?
Okay, so a coronal hole is an area in the sun. And you know, the coronal hole is the top part of the sun's atmosphere, and it's the hottest part. And out of it comes the solar wind. So when you get a coronal hole, you get a lower density in certain areas of the corona. So there are less particles, and what happens is it gets darker because of the lower density and the temperature drops. But the reason why the coronal hole itself forms is that the magnetic field lines coming out of the surface of the sun through that area of the coronal hole are seemingly open. They don't curve like they do where there are plasma loops. So they just jut out of the surface of the sun. And when they do that, what's called the coronal hole, that's when the density decreases. And when the fast solar wind comes out of the sun, it actually curves around the magnetic field lines, and out it goes out of the sun. So that drops the temperature and the density, and it looks darker.
That's a dang great explanation. On Wikipedia, just for the listener, it mentions that coronal holes are areas where the sun's corona is colder, hence darker, and has lower density plasma than average because there is a low energy or lower energy in gas levels. Coronal holes are part of the sun's corona and are constantly changing and reshaping because the corona is not uniform. I've only got two more sentences here. The sun contains magnetic fields that arch away from areas in the corona that are very thin due to the lower levels of energy and gas, which cause coronal holes to appear when they do not fall back. Thus, solar particles escape at a rate enough to create a lower density, like you had mentioned, and lower temperature in that area.
Mm-hmm. Yes.
What we're looking at is the document you had put out for March 30th, 2017. What does the sun have so many why does the sun have so many coronal holes? And I've kind of just jumped in here. Can you talk a little bit more about this document and what we're looking at now?
Okay, so the key thing about what I have to say in this document is that there is no such thing as an open field magnetic field line. All magnetic field lines form loops. So the loop, the magnetic field lines that come out of the coronal holes must close and form a loop somewhere. You see the thing to the plasma loop there? That will form a closed loop. It closes inside the sun, and we see there what the part that's outside the sun. And inside the sun, it will close, it will form closed loops. But the ones out of the coronal holes seemingly do not close. And my point is they have to close. They have to close somewhere. So the fact that it looks like they're open means that the sun is connecting to another object that also has a high magnetic field. And then what that does, it causes a particle flux connection between the sun and that object. And it's difficult to draw. That's why I just draw straight lines. The particles actually have a curved path around the field lines, but overall they move away from the sun. But the field lines have to connect to the other object and then come back to the sun to form closed loops. That's the only way. Everybody who has studied magnetic field knows that magnetic field lines have to form closed loops, and this is the key thing here.
So I've noticed, you know, as I've mentioned before, time and time again over the past year, you know, we just keep seeing these coronal holes opening up time and time again, constantly, and I keep repeating and reiterating that there has to be something that is, you know, helping the sun along with these coronal hole openings. And the more and more research that I do, and the more that I read your reports, the reports are, you know, very, very informative. And I've learned a lot from your reports. And, you know, I just have to say that, you know, I mean, for me right now, it is beyond a shadow of a doubt that it seems the sun has made some type of, you know, magnetic or electrical portal connection with something, and something is using the sun's energy, and it is just opening up these coronal holes. And what I wanted you to touch on for a lot of the viewers, once again, whenever these coronal holes open up, they refer to this as the solar wind, but in actuality, it's really not a wind, is it?
No, it's particles escaping from the sun, because the corona is actually
I think she might have muted herself.
There she is.
Oh.
Doctor, are you there, buddy? Oh, yeah, we couldn't hear you for a second. Could you go ahead and repeat yourself? Thank you.
Okay, so when there is a coronal hole, there's a lack of corona there. The density is lower. And when that happens, the solar particles from the surface of the sun are able to escape. And when they escape at high velocity, much higher than the normal solar wind, which originates somewhere in the sun's corona. So this fast solar wind comes from further down, and basically it's a lot of particles leaving the sun that the corona would stop from leaving if it was there. So that's what's happening here. So that's what gives rise to the fast solar wind, and it increases the cosmic radiation coming off the sun, because some of the particles come at extremely high speeds, and to the point that they become relativistic. That is, they get close to the speed of light. And I've written about these particles before, not in this article, but these particles are cosmic radiation, and the Earth does not, the Earth's atmosphere does not actually protect us very well from this cosmic radiation. So these are high energy relativistic particles that hit our atmosphere, and they cause cascades of particles and gamma radiation, and they are harmful to living organisms. They cause mutations and therefore lead to cancer. So that's what's happening when we have large amounts of coronal holes. So the Earth is impacted and affected.
There was something that I wanted you to touch on, and I've had this debate with others over and over and over again, and I've read other scientific papers pertaining to these particles as they stream towards the Earth and they impact the Earth. They have the ability to impact and penetrate all the way to the Earth's core, therefore heating up the Earth's core, and that is the reasoning for all of the increase in earthquake activity. I mean, I've read 2 papers on this, both of them published scientific papers, but yet there are still the naysayers, and they sit there and they tell you point blank, there is no relation to or from coronal holes to earthquakes. Now, do you find that true, or do you have a difference of opinion?
Well, there's definitely a connection. If anything, I mean, you can think of it as very extremely high energy particles and being able to penetrate into the earth. I mean, there are particles that are very unreactive, like neutrons and definitely gamma radiation. If it's very high energy, would be able to penetrate. The ionized particles probably would not penetrate that far unless the energy is beyond anything we've ever seen. And it is possible that sometimes cosmic radiation particles are caught that have energies that are beyond anything anybody has ever imagined. But these usually come from outside the solar system. So, but it's possible they're coming from the sun as well. But even if the particles do not penetrate, there is still magnetic induction, or Faraday's law, where these objects, the magnetic field affecting the Earth, will cause a magnetic induction effect, which will penetrate right into the mantle or into the core, and that itself can cause the mantle to warm up, to heat up.
Yeah, because I mean, I notice every time they give a report or a warning or an alert of severe activity on the sun, they're always letting people know, okay, listen, watch for major earthquakes. So it's kind of like a hypocritical situation. Yes, they these solar streams and the solar wind, yes, it definitely has an impact on Earth related to these earthquakes, because every single time we see these coronal holes, right then and there, you get the warning, an earthquake activity warning, from different sites, namely Suspicious Observer, his YouTube channel. I mean, he gives these alerts all the time, and he's very, very accurate in the predictions of the earthquakes, in direct association with these coronal holes.
Yes, but Scott, there could be an indirect relationship as well. Because when you have a coronal hole, it means the sun is connecting to another object.
Yeah.
And this other object has its own magnetic field, which will affect the Earth. And especially if the coronal hole is facing the Earth, that means there is an object that could be behind the Earth or just in front of the Earth, connecting to the sun. But either way, it is able to affect the Earth's magnetic field. It's able to, through induction, cause the mantle to heat up and change in certain ways, and that can cause earthquakes. So it could be a direct relationship, an indirect relationship. It could be both.
Let me jump in. Two questions. One, Scott, can you pan down a little bit in the document to not figure 2, but figure 3, which shows the sun connected? Yeah, there you go. Can you explain to us what particle induction is? And then can you explain to us what we're looking at? Do you mind?
Okay. So magnetic fields are usually generated by a coil. Okay. So you have a coil, which is wire, and you have a current flowing through the wire, and that generates a magnetic field that looks almost like a bar magnet, except the ends of the magnet are the ends of the coil, or if it's a long coil, we call it a solenoid. Now, whenever we change something to do with the current in this coil, we will change the magnetic field generated by the coil. And whenever there is a change in the magnetic field, and if we were to put another coil next to this coil, whenever this magnetic field in the first coil changes, a magnetic field is induced in the other coil without it even having a current flowing through it. In other words, a change in the magnetic field in a place where a magnetic field can be generated can cause an induced magnetic field in another place which can be generated as well. So if you have two objects with magnetic fields, say you have a brown dwarf, it's rotating, so that means its magnetic field is changing. It will cause a magnetic field to be induced inside another object that's close to it, like a planet the Earth, for instance. So the Earth generates its own magnetic field because it's got currents inside the mantle and so on. And when a magnetic field close to the Earth changes, the magnetic field inside the mantle will change as well. And when a magnetic field changes, it causes a change in electric field, which then causes currents. And currents lead to resistance and heat.
Is the material that the star made up of a large factor in it producing its magnetic field?
Definitely, because obviously the denser the star, the more collapsed it is, the faster it will rotate, the more its magnetic field will change. And the fact that it's condensed has already also made, say it's an iron core brown dwarf star, which it would be the densest that we would get, then it would generate an extremely high magnetic field because of that, its collapsed state. It used to be a very large star because to become an iron core brown dwarf star, it had to go through all the stages of fusion reactions before it turned into a white dwarf. And then it cooled down, became a brown dwarf. So it used to be a huge star that had a huge magnetic field. It collapsed to a small core of a star, but that magnetic field is now very condensed inside this object. It's rotating very fast, changing very fast. So it will have a very strong effect on any planet close to it. And maybe that's why these brown dwarf stars have come into the solar system. And what we have observed is all the planets in the solar system have heated up. And that could be because of the high magnetic fields and the quick changes in the magnetic fields of these objects. Does that explain it, Chris?
Very interesting.
Absolutely. So what we're looking at here, to me,
yes,
is that brown dwarf star, or we'll say alleged brown dwarf star or rogue object in our solar system, appears to be draining the sun and creating a coronal hole. That's what my observation is in this diagram.
Right.
It looks like in figure 4 below, if you can pan down again, Scott, to the next figure, it'll show a big juicy purple sun with a large coronal hole in it. And that's what we've been seeing. I know that Scott is an avid viewer of SDO, SECI, SOHO, as well as you are, and you both can speak to this more than I. This coronal hole is not going anywhere, is it? And it's on the bottom of the sun. Can you speak more about that too, please?
Okay, so it looks like there's a permanent coronal hole at the south pole of the sun, and that is. It means that it's connecting to an object that's at the south, below the south pole of the sun. That's the only reason we could have a permanent coronal hole there. So, I mean,
what about like Venus and Mercury and our moon and the Earth? Like, don't planets have any? I mean, I don't know, right? I think that we've kind of discussed that only stars have the potential to do that energy draining and to create a coronal hole. And there's other reasons for coronal holes being created naturally outside of an object being there. But I don't believe the object can be a planet. That gets me into the discussion of, can planets have these plasma ejections, and can they have these CMEs that we appear to be seeing in the footage that are labeled as Jupiter, Venus, etc. Maybe I'm kind of going all over the place, but I guess what I'm really leading into, if you could speak more about why it couldn't be a planet.
Okay. All right. First of all, Venus does not generate its own magnetic field. It seems that only planets with an iron core produce a magnetic field. Also, they have to have, it seems to, I mean, we cannot be completely sure, but we have to be able to have maybe a liquid mantle somewhere where the currents produce or able to produce this magnetic field. So the Earth has an iron core and a liquid mantle. But apparently Venus is different from the other planets. So we do know it does not generate its own magnetic field. It does have an induced magnetic field due to ion exchange between its atmosphere and the solar wind. So it gets what's called an induced magnetic field. And all comets that come into the solar system produce the same kind of thing. Their coma and tails are produced by an exchange with the sun's solar wind. So they also will get an induced magnetic field. But the Earth does have its own magnetic field, but it's not nearly as strong as the magnetic field of a star. A star, the sun produces a magnetic field that could be felt and measured at 100 AU. That is 100 times the distance between the sun and the Earth. Whilst the Earth's magnetic field is much more local and close to the planet itself. So the sun produces a huge magnetic field, and it produces the bubble around the sun, which is in size is about 100 AU. So you can see from there that it's a big difference. So stars produce huge magnetic fields, and planets produce, if they produce magnetic fields at all, very small magnetic fields. And stars also produce plasma because they have this turbulent flow of gas on their surface, and it's hot, and it's got very high currents and produces a huge electric field, and then this gas is ionized, and that's what a plasma is. So it gets very hot and ionized. And I believe in electrical theory because I don't think a sun powered by thermonuclear reactions from the interior can go dark as we see the sun go dark. So through my own observations, I have come up with my own theory that the sun is electrical in nature, and it's got potential energy. And but it does also have fusion reactions. We have to have fusion reactions in order for stars to be able to become brown dwarf stars. So if it never runs out of energy and its fusion, it will never form into a brown dwarf star. And we have evidence that we must have brown dwarf stars with clouds of ionized gas around them. So it must be both. It's both electrical and powered by fusion reactions, but not from the interior. Because we can see in sunspots that the interior, the surface or interior of the sun is darker than the corona and its atmosphere. So it's got to be that the thermonuclear reactions are happening on the surface and possibly in the atmosphere. And it may have a lot to do with these plasma loops where sometimes the temperature goes extremely high and it goes right up into the corona and heats up the corona, and may therefore explain why the corona is hotter than the surface of the sun. So the surface of the sun is ionized gas and it's very hot. That's what a plasma is. None of the planets produce the kind of temperature that a star produces. So the sun has a surface temperature of 5,800 Kelvin. But the corona has a temperature of millions of degrees Kelvin. And there is no way any planet can produce anything of this. We have ionized particles in the upper atmosphere of planets, but they're not hot. And they do not eject a plasma that is so hot that it glows so bright as we see the sun do. And other stars should be able to do the same thing for the same reason. Have I answered all those questions, Chris?
Yes, ma'am. That large hole that we see,
yes.
Going back to the very first question that I asked you, what's your understanding of a coronal hole? And then I just read the Wikipedia explanation. Just to play the devil's advocate, what other reason would there be for this large hole?
Other reasons.
We'll rule out a star, round dwarf star, cheese sandwich, planet, whatever. We want to say what other natural or known reason, according to our understanding in physics, science, astrophysics, etc., that you know, why we would have such a large coronal hole.
Okay, so the expected reason does not actually give you a full reason. It just tells you that the field lines open up and don't fall back like they do in the case of a plasma loop. So that's what you will read about.
Yes, exactly.
Okay, so that's what they will say. They will not go any further than that. As I said, the key factor is that there is no such thing as open field lines. They have to close somewhere. So therefore, it means that you get open field lines because the sun's connecting to another object. And if it's connecting to another object, there's another object there. So to me, the only reason why we could have a coronal hole is because the sun is connecting to another object. And the fact that these coronal holes are growing larger, to me, it means that either the objects are getting closer to the sun and affecting it more and more, and their magnetic field lines are connecting to the sun more and more, or it means that there are more objects around the sun.
Okay, I'm going to ask another question. I'm not trying to run the conference that we're having, but I think they're relevant questions to what our viewers are asking. What other effects would the sun be going through to make it? I mean, it looks sick. The sun looks sick. It's having a problem.
Okay, yes.
It's having a bad day.
It is. And
what
if you
is it gonna?
Yeah,
I was just gonna. Is it gonna go into a? Go ahead. I guess that's the appropriate question to ask.
Okay, so what we see is, you can see from the color of the areas where there are no coronal holes that it's darker. So the image on the right here, it looks a lot darker than the image on the left. And the image on the left is a year ago, from March of 2017. Actually, it's from 2 years ago. But if you have seen the images lately of the sun, it looks even darker than this. These patches where there is sun.
Just looking at. Sorry.
Yeah.
We were just looking at that, right?
Yeah.
Okay,
so
sorry,
the sun looks like it's getting weaker. It's producing less and less ultraviolet radiation from the corona, which shows that it's getting weaker. It's not able to sustain the same kind of emission that it was able to before. And the coronal holes are getting larger. And the fact that it's getting weaker may mean, that may impact the fact that the coronal holes are getting larger. It doesn't mean there's no object it's connecting to, but it means that it's not able to fight off the effects of the other object as well as it did before. Okay, so maybe it's that. But this does not mean that the sun is dead. I have seen evidence that the sun sometimes becomes very unstable, and it has extremely large explosive reactions to certain objects being close to it. So the sun is not dead, and it is still able to cause a lot of damage to any planet that is in the way of those explosions. And these I don't even want to call them CMEs because they look larger than normal CMEs. So the sun is still dangerous. These objects are causing instabilities in it. It still is a very powerful engine that produces a lot of energy and is able to produce a lot of explosive reactions. So we have both things. We have the sun getting weaker and producing less radiation, and we have potential for explosive reactions as well. So this is what I can say about that.
You know, I had a very interesting question that just popped into my mind. You know, sitting here looking at these two photographs from 2015 and 2017. Mm-hmm. For instance, if the sun was losing a lot of its energy, and based on what we're looking at between these two photographs from the SDO, mm-hmm. and the sun going dark, as we're just saying, losing some of its color, you know, pertaining to these two photographs, would we see a difference in light here on Earth? Would we see a difference the way that the Earth is lit up, illuminated during the day? Would we be able to notice this?
Yes, yeah. Okay, Scott. I believe that we should see a difference because from what I've seen, the visible light emission seems to be even more affected by these objects than the ultraviolet emission. So when the SDO, so-called eclipse, happens, I have actually discovered that the visible light emission goes out first and comes back last. So visible light is definitely affected. Yeah, so definitely the sun would probably look different to us because of this. I don't know how many times we actually look at the sun, though, because the objects that we think of as the sun don't even look like the sun. I mean, the sun is supposed to be yellow inside our atmosphere, whilst the objects that are now sun are sometimes white, sometimes blue and magenta on the outside. They definitely do not look like the normal sun.
Yeah,
Yes,
I took some photographs yesterday. I took some photographs yesterday of the sun, and it actually changed its shape 3 times in 30 minutes. It went from a perfectly round disc, and I mean perfectly round. And I went and took 3 photographs from 3 different locations, you know, and I was just doing my routine. And then it went from this bright, round, illuminated disc to something that looked like, you know, I'd say like a diamond shape, a vertical diamond shape. And then I went to another location just, you know, 5 minutes away, another nice clearing where I could get a perfect shot. And instead of it looking like a vertical diamond, then it turned and looked like a horizontal diamond. But there was no illumination like you would see the corona in the photograph to the left. All you're seeing is just a white disc. That's it. I mean, it actually had lines going across it, horizontal lines going across it, and it almost looked like an old-fashioned SOS light on a Navy ship with the shutters on it. Like they would open and close the shutters. And just after I took those photographs and came home, one of my subscribers was out taking photographs of the sun at the same time on a different side of the United States. And when he emailed me his photographs, they looked exactly like mine. Perfectly round disc, white, and it had those horizontal lines going across it. So, you know, I know for a fact that, I mean, it wasn't my camera, but both of us have, you know, broken cameras.
So it wasn't the camera. And I was going to ask about that. Let me ask you, didn't you also say that your face was burning weird and that you didn't see any shadows on the street? Yeah,
that really freaked me out because the way that the sun was illuminating the entire street, there were absolutely no shadows, nowhere. I was standing about, maybe 15 feet away from a tall telephone pole. And when I started to, I turned around and I'm looking for my own shadow and I did not see it. Yeah, and then I started looking around at other objects, the telephone pole, you know, where my car was positioned, where I was, and I was like Peter Pan without, where's my shadow?
And that's what I remembered, and I wanted to make sure that you mentioned that.
Yeah, and everything looked like I was in a studio. You know what I mean? The light looked fluorescent. It did not look normal. Now, last summer, through the months of June, July, August, going into September, I was photographing the sun. I was photographing the sunset. But hours before that, normally like around 4 o'clock in the afternoon, between 4 and 5, I would notice this effect. And, you know, I started asking different friends of mine. I would go over to their house and I would say, hey, listen, you know, mind if I take some pictures of the sun from your property? And then I would ask them, listen, do you notice anything different in the color of the sun and the lighting? And when they would come outside and start talking to me, you know, they're putting their hand over their eyes and they're like, yeah, it is kind of bright out here. And, you know, I said, well, do you notice the way that the sun looks, you know, the lighting outside? And then they start to understand what I'm talking about. And then they start to notice the look of everything around them. It's very weird. It's very hard to explain, but I've gotten thousands of emails from people stating the same thing, that, you know, it just doesn't look right. It looks magnified. And when you're standing outside in the middle of January in the northeast part of the United States, you should be freezing. And even though the sun is hitting your face and your skin, you can barely feel the warmth of the sun. But this January, this winter, you can go outside and, you know, when I would be taking photographs, within just, you know, a minute, I can feel the burning on my face. And I'm not the only one saying that. I got thousands of emails, people telling me the same exact thing. It was 25 degrees outside. I was taking photographs of a sun halo. And as I was, you know, looking up into the sky, taking the photographs, the sun was burning my skin.
Exactly.
So it's like it's magnified through what we all know. It's maybe some type of a sun simulator, something to hide what is actually happening to the sun, something that's able to produce natural looking light. Because I think if the sun was going this dark, how would it illuminate one half of the earth? Because people would notice that.
That's right.
The days would be dim. They would be very dim.
Yeah.
Well,
also this.
I was gonna throw something in there. I'm just gonna kind of throw it.
Go ahead.
Okay, go
Throw it in
ahead,
there.
Chris.
Throw it in there, Chris.
Why? Well, that's actually a very interesting scenario that, you know, if the sun's freaking out, what would we see here on Earth? I think that's a whole topic on its own. I think we should kind of soak on it for a while, you know, soak the information in and maybe come back to it at a later time because I think it's a good topic. Excuse me.
Okay.
Why do you think that it's not that it has to be a brown dwarf star? Why is it not a white dwarf? Why is it not a neutron star? That's actually a subscriber question that just came to me.
Okay, neutron stars are actually, well, they are theoretical objects, a little bit like black holes. It is.
Oh.
So
sorry.
What happens,
go ahead.
No, that's fine. That's fine. I can explain what a neutron star is. So what happens is if an extremely massive star, so a brown dwarf star comes from a main sequence star that is not that massive. Okay, it goes through. It doesn't even have a supernova. It just runs out of fuel, gets to the point. Well, it may have a supernova, but most of them don't even have a supernova. They're not massive enough to become unstable enough and have the supernova thing. So that they go through a red giant phase, and then eventually the red giant phase has very diffuse gas on the outside, and when it runs out of fuel, the core collapses and the outer layers are just shed. They move outwards and they form the cloud of ionized gas. But more massive stars, and according to the gravitational theory, okay, and remember, I don't subscribe to the gravitational theory, because I don't mean that gravity doesn't act in the universe. It's just a lot weaker than the electric force. So, yeah.
Force and theory.
So,
gotcha.
Yes. So, when a star runs out of fuel, and the theory is that thermonuclear reactions act against the gravitational collapse that the star would feel because it collapses under its own gravity and tends to come down to a point in the center. So all the matter on the surface of the star is attracted towards the center of the star. And it's supposed to be thermonuclear reactions in the center that stops the star from collapsing. But once the star runs out of fuel, then it cannot stop the collapse. So it starts collapsing to the point that atoms that are made out of protons and neutrons, that's in the nucleus, and electrons outside. So the electrons are squeezed towards the nucleus to the point that the proton and the electron becomes a neutron as well. So you end up with just neutrons. But the problem is just having a star with neutrons in it is not stable. You basically have a huge nucleus, and a huge nucleus of just neutrons is not stable. It should fission and break up into pieces. So the theory breaks up at many levels. But the whole theory came because of these variable stars that emit high energy pulses, usually X-rays. And it was thought that they work like lighthouses. So they're rotating very fast. And if they rotate very fast, they have to be a very small size. And it was worked out that in order for them to rotate this fast to produce this lighthouse effect, they have to be very small to the point that this would happen, that the electron, it gets pushed into the nucleus. And the only thing that stops the star from collapsing any further is the strong force inside the nucleus. So the whole thing is the way, you know, most astronomers think of these things. And as you know, through my own studies, I don't subscribe to a lot of these theories. So I think actually these variable stars are actually stars that are emitting high pulses of radiation, and they're not necessarily due to their rotation. So they just emit, and then a pulse, and then another pulse, and then another pulse, and they don't have to be rotating as fast as it would be required if they were just emitting in a single direction, and they had to rotate 360 degrees to then, within a few milliseconds, to emit in the same direction. Okay, so I don't, that's why I'm not sure that neutron stars actually exist. No one has actually observed one. So there are theories to explain what happens with these pulsars, which are stars that emit these high energy pulses with a very quick period of time between them. So
thank you.
Yeah. Okay.
I've got to leave at about 5. I'm not sure how long we're going to continue. I just wanted to go ahead and let you guys know that. I guess if we're going to just continue and I cruise and the two of you talk and finish up.
Okay.
Figure 5, exactly. You read my mind. I was wondering what the doctor thought about figure 5 and 6 and what we're looking at.
All right. So
the point where we saw that comet impact, Chris.
Thank you. You read my mind.
Yes, that's right. Yes, so we saw this comet impact, and we could see, I mean, you see the time difference between the two images? The one on the left is 2354, and the one on the right is 0009, so that's 15 minutes difference between the two. And we could see that from the way the comet was moving, that there was no way that it could have gotten to the sun in that time. So what we see on the left is the comet approaching the sun. It's almost at the occulted position. And then 15 minutes later, we see that dark shadow below the sun disappear, and we see very bright emission there, very bright explosion happened there. And that explosion is still very far from the sun. That is, I mean, over what the radius of the sun is. And there was no way the comet could have traveled that distance in 15 minutes. Okay, it's a very large distance. The sun is a very large object. So obviously the comet impacted something that was there that we could not see before. But what we could see was a dark shadow. I mean, what could possibly be a dark shadow? It's obviously something that it's absorbing light, not emitting light. And what we'd expect to be there that's not emitting light, some kind of cloud, some kind of object that doesn't emit light. What kind of objects do we know about that don't emit light and have clouds around them? Yes, brown dwarf stars. But how could a brown dwarf star be permanently stationed below the sun? How is that possible? Well,
back to the question. That's right.
Exactly.
Go ahead. Back to the question, why is it magnetically connected?
That's right. So the only thing I could come up with, it goes with the fact that we seem to have a large amount of objects that are basically stars attracted to our sun. Why would they be in close orbits around the sun and seemingly somehow getting closer and affecting the sun more and more? And the only thing I can think of is that stars attract each other just like protons attract each other. In the electrical theory, stars are positively charged just like protons in the nucleus are positively charged. Attracted to each other because of the strong force. So the only thing I could think of, my goodness, it looks like stars are attracted to each other by what seems to be the strong force that we also have in the nucleus. And therefore that gave me the idea that perhaps the strong force acts on an astronomical scale as well as inside the nucleus. So if that is the case, it could be that one of these brown dwarf stars found a stable position right below the sun. And then if it's in a stable position, it's like two magnets coming together and just sticking close to each other. Okay? So
you had explained that strong force had the ability to not only repel but attract objects. Is that what you're speaking of?
Okay, now what repels the objects is the electric force, because two charged objects repel each other because of the electrical force between them. Because the electrical force is such that two oppositely charged objects attract each other, and two likely charged objects, so like two positive objects, repel each other. So two protons repel each other. But in the nucleus, they attract each other because of the strong force, which is stronger than the electrical force and overcomes the electrical repulsion that you get between the two positively charged protons. So I would think that stars, because they're positively charged as well, would also repel each other. They should, according to the electrical theory. But the strong force that they feel is stronger than that. So you might get the two effects. So that's why you may see that maybe the sun jolting, because as a star comes close to it, there's the electrical interaction and the strong force, sort of jostling for position. And the two objects are looking for stable interactions between them. So it could be that this brown dwarf star somehow found a stable position below the sun. And now the two are traveling through the galaxy together. That's what I show there. Okay, because this is the only explanation I can come up with for what I see in these images. Now, it could be that all these stars will eventually find stable positions around the sun. So what that would create is basically a larger sun. The sun itself would become the core. It would become just a coronal hole. The other stars would then produce the light that the sun should be producing. They become the outside of the sun or the core. But now these stars are not main sequence stars. They are acting. They are still able to have potential energy, and they obviously got most of their potential energy from the sun. But they are made up of different things. So the light they will produce, the radiation they will produce, will never be exactly the same as the sun. So what we would get in the end, I'm not sure, but I don't think it will be the same as having our sun. But we may still get light from these stars. I think we're already getting light from these stars. That's why we get these peach-colored clouds, these pink clouds, blue clouds. I think these stars are emitting different frequencies of light that in the visible range look like different colors. And because they're around the sun, they maybe when the sun sets, one may be just above the sun. So the sun sets, and the sun may still be producing more light than these stars. But when it sets, then its light doesn't hit our atmosphere. And if the star is still the other star's light is still able to impact our atmosphere, then the atmosphere will reflect this light. That's why then we'll look peach and pink and yellow and all kinds of colors.
Awesome. I got to hit the road. I'll talk to you guys soon.
Okay.
All right, yeah, Chris.
Okay.
You take it easy.
Bye, Chris.
Yeah, Doctor, I just had a few more questions for you. As we were looking at this this diagram of the sun and this brown dwarf illustrated below the sun. Now, I've read several articles pertaining to exoplanets and actually, regular large-sized planets orbiting brown dwarf stars, like their own little mini solar system. So, over the past year and a half, we've had so many people, photographing with telescopes and just seeing things in the nighttime sky, the daytime sky, things that we cannot explain. But there is a possibility that this brown dwarf or any brown dwarf can have multiple planets orbiting around it, just like we orbit around our sun. Is that correct?
Definitely. I mean, these brown dwarf stars probably have planetary systems. I mean, not all stars have planetary systems, but a large percentage do. So it's possible that a lot of them do. it could be these brown dwarf stars were once stars that were larger than our sun. And therefore, they may have had even larger planets orbiting them than our sun does. So it is possible that there are even gas giant planets. It's possible that there are brown dwarfs, where I mean the substellar objects that are between gas giant planets and small stars that are part of the system and that are orbiting some of these brown dwarf stars. And that may be the planet that I think you photographed that has stripes in it, which is characteristic of a brown dwarf. And I mean these substellar objects. So don't forget, I differentiate between the two, the brown dwarf and the brown dwarf star. So what we have here in the image is a brown dwarf star. That's what can produce these huge magnetic fields and have plasma ejection, so on, because it's a star. Whilst a brown dwarf is actually more like a gas giant planet, more like Venus. It can also produce a high magnetic field because it's quite large, but it doesn't have plasma ejections.
Yeah, because I often wonder about that, and if in fact this brown dwarf star actually did take a position, a stable position below the sun, then that might be the answer to what people are actually photographing with telescopes. I mean, I got some amazing photographs back in August and September from an individual that lived in Germany that was using a very nice sophisticated telescope with camera equipment and a laptop. And this lady sent me some amazing photographs of that striped planet. And then later on, I lost contact with her in October, and it was just about the time when the whole incident with the United States supposedly turning the internet over to the UN. And approximately 5 days later, I never heard from her again. I tried to email her back, but her email address no longer worked. The emails just kept coming back to me, not being able to be sent. But we were able to capture this other striped planet. I'm not the only one who has seen it. There have been hundreds and hundreds of other people that have seen it. It's so close. It's not Jupiter, because at the time, Jupiter was nowhere near near the sun in these positions. Nor would anybody be able to capture such a close-up photograph, and then to see it on these webcams from Australia. And once again, I'm not the only one who has seen this. There's probably thousands, tens of thousands of people that have seen it, sent photographs in. I have so many of them, but it makes me wonder that this is probably the possibility that this is what people are seeing, these other planets orbiting.
Yes.
And we haven't had that many sightings. I would say probably as we went into the fall of 2016 and then into the winter time in the northern hemisphere, it just seemed like the sightings of the planets kind of slowed down. Then all of a sudden we started getting a lot of photographs from people in the southern hemisphere, New Zealand, Australia, the very lower parts of South America, Argentina, and Chile. So, I mean, this is just my thought that it's a possibility that, just the way we were making
definitely
around the sun, for our seasons, and we have different seasons, northern and southern hemisphere, that now everyone in the southern hemisphere, they were seeing what we were seeing in the northern hemisphere.
Yeah, definitely. That's a strong possibility. I mean, these planets, depending on their orbits, they could be close to the stars and therefore would stick close to the sun, or some of them stick close to the sun because they are orbiting their own star, which is close to the sun. Or they could have orbits that would send them further out. Now, you have to remember that I don't think there's much danger of planets colliding, because planets repel each other. They're both negatively charged, so they would repel each other. They may come close to contact, I suppose, but they wouldn't directly fly into each other, I don't think.
Yeah, and I'm sorry, go ahead.
Yeah, it just asteroids that are the unknown equation here. they can impact planets and stars and whatever, because yeah, they're not like planets. They don't have the same characteristics that planets belonging into a solar system. And it's interesting that I'm thinking more and more of planetary systems as atomic systems, atoms, you know. The stars are in the nucleus and the planets are the electrons, the electron part of the atom. It's fascinating, actually. Sorry,
Yeah.
did I answer your question?
Oh yes, absolutely. Now, earlier today, I did a video on Major Ed Dames, and Major Ed Dames,
Yes.
he worked for the United States government. He was in the military. He was part of a secret program of remote viewers, you know, similar to psychics. But this whole remote viewing program was pretty interesting, put together by the United States military, and he spent 20 years in this this operation, and then after retiring from the military and going through, I think he had the non-disclosure agreement, where he was not allowed to talk about anything that he did for, you know, a certain period of time, naturally. But then he went into what you would call like a private practice, and he was actually doing remote viewing for major corporations around the world, and remote viewing pertaining to the corporation's competitors and also world leaders. You know, he was traveling and doing seminars and things of that nature, and a lot of people have tried to discredit him and debunk him and, you know, blah, blah, blah. But one of the last seminars that he did, he actually had several more scheduled after August of 2016. But he was doing a remote viewing session prior to this seminar in Las Vegas, Nevada, back in August of 2016. And he stated that, you know, what he saw during that remote viewing session before the seminar actually scared him more than anything that he's ever seen in his life. And that was a lot of the remote viewing was pertaining to the sun. Now, he does take questions and answers from the audience at the seminars, and someone was asking him specifically about, you know, Planet X, a brown dwarf, Nemesis. You know, they were throwing all of the pertinent names out there, and he was kind of vague when he talked about it, but he did say that he is not discounting this Planet X. And then later on, after the seminar, he gave a private interview, and in that private interview, he actually came out and said that, you know, the presence of this, quote, Planet X is real. It is there. It is not something that is going to directly collide with the Earth, but the effects that it's going to have on the sun will be very detrimental to every human being on the face of this planet. And he further, you know, in the video that I did today, I actually used part of his interview. And, you know, he did state that, you know, this will cause worldwide power outages similar to, you know, an EMP pulse. This will cause catastrophic earthquakes, severe flooding, and volcanic activity. And this will happen systematically as things with the sun and the interaction between this Planet X or brown dwarf star start to affect the sun in ways that will eventually affect the Earth. And we're starting to see all of this. And one thing that caught me in his interview is he talked about Africa. And, you know, I wanted to talk to you about this, because he said that you will see things on the continent of Africa that they have never seen before. Catastrophic, you know, catastrophic destruction, earthquakes, and, you know, things of this nature. And then he talked about safe zones, and he said basically that every land mass in the southern hemisphere will not be safe. There will be one small area in New Zealand, one very small area in Australia, nothing in South America, and there will be some very small safe zones in Russia, Poland, and in the United States. But he basically stated that the entire Southern Hemisphere will be a complete loss. So, I mean, that kind of goes into what we're talking about, the positioning of this brown dwarf. And he said the sun will start to look like it's going to sleep, it's losing energy, it's losing power. And then, because of the interaction, it will literally come to life so fast that we won't have any time. Now, we just saw that again. You know, first of all, we saw the earthquakes already in Africa. We saw 2 earthquakes a few days apart. One of them, you know, they labeled as a 6.5. We know that it was much stronger. And right before that was a 5.2. And we're starting to see this activity in Africa. And everything that he was talking about, you know, in this interview that I used for my video was a few years ago. You know, this wasn't just the other day. This was actually a few years ago that he was talking about the situations that are going to be occurring around the world. And as I listened to this again, and it all started to just come to me that everything that he is talking about is actually happening. You know, and it's, you know, I mean, he basically said that the world will be forever changed. Mankind will not be wiped out. There will still be living, breathing human beings on this planet, but they are going to have to recover and rebuild. And he said the electrical grid, as far as power around the world, will be gone. And that will take years for it to be rebuilt. And, you know, he talked about preparation, you know, food, water, you know, medical supplies, things of that nature. You need to prepare yourself now because we don't have a definite date. And he really refers to what he refers to is a kill shot. He's referred to it for several years. And that's where the debunkers jump all over him when, you know, he was talking about this and, you know, making predictions. But he does state that we just don't know the exact timing of something like this. And, you know, just last week, we saw this massive coronal ejection from the sun. It was by the grace of God that the Earth was not in the stream of that coronal mass ejection. We probably would have been toast. But, you know, I mean, thinking about all of this and, you know, producing that video today, because I wanted everyone to see that people have been working on this and researching this for a very long time. And it's not like people, these are uncredible people. You know, he has nothing to gain by scaring the living daylights out of people. Even though people pay to go to his seminars, he was actually, you know, helping and instructing people how to become remote viewers and holding classes and, you know, the whole 9 yards. But everybody thinks it's not right to create a business and make money and support yourself with the knowledge and the skills that you were given. You know, that would be the same as you know, spending all of these years in college and then just sitting at home with 5 degrees under your belt and doing nothing to make yourself a living. But when I listened to him, you know, when I listened to him again today, it brought back the memory from this past August. And after his last show in Las Vegas, he had other seminars scheduled after that. He canceled all of them. And in his private interview, he stated, "There's nothing else that I have to say. I have said it all. There's nothing else that I can do. And this is time for me to step away, retire, and spend this rest of this time with my family." And he walked away after all of these years, canceled the other seminars, and just walked away. You know, and that just, you know, that I remember that so vividly from this past August, because I was willing to travel wherever his next seminar was because I really wanted to see him. I've been following him for over 5 years now, and I've watched, you know, a lot of documentaries on his work, and a lot of people try to discount it, but the information that he gave about, Africa and the earthquakes and the volcanic activity, it just really hit home with me this morning when I woke up and started, working on some of these things. It just really hit home with, South Africa having that earthquake last week, actually two of them. And, he also mentioned the severe changes in the weather patterns. He had mentioned at one point in one of his other interviews that he said that there will be places on this earth that have horrible winter times that people don't look forward to, but you'll know when you're getting close, because those people that can't wait to get out of the winter time, they won't even have a winter. They will have warmer temperatures, a complete climate change. So
I see that's what's happening, isn't it?
Yes, it is. I kind of got a little shock this morning when I woke up and I started thinking about these things, because my mind just works very rapidly, early in the morning. And when I started thinking about this and I started fitting the pieces of the puzzle together, and they fit together perfectly. And I think that we are truly living in the sign of the times. This is the sign of the times. There's so much going on around the world right now, so much that people don't realize, people do not see, unless they're really looking for it. These catastrophic floods and landslides and this crazy climate chaos. And yes, the earthquake activity has heated up since last week. And I mean, I think it's just a matter of time, but I guess there's no way to definitively put a date on something like this when you have so much against you as far as gaining the information. Just like when we were trying to prepare for this live stream. I mean, it took 45 minutes just to get computers to work, just to, try to get to the SDO and other government sites to look at things, and they're all shut down. So they definitely do not want us, I guess, publicizing the information. But it's going to happen.
I think they do like what we did yesterday.
Oh yeah. There's absolutely no doubt. I think they're also learning some things from us. And it's kind of funny that I was reading some of the comments in the live chat that goes along with our live stream. And I just can't help to laugh and sit back and think how ridiculous some of the people in the comments section, all of a sudden, these are unemployed idiots without a job, and all of a sudden they are scientists, physicists, astronomers, astrophysicists, and it just seems like they're reading from Wikipedia. One of these idiots even mentioned something about pseudoscience. And I was actually very surprised that this individual was able to spell the word pseudo. But it's very easy to, copy and paste something from Wikipedia. But anyways, did you have anything else that you'd like to add?
No, I would like to say that I've always thought that Africa is a very stable continent. It hardly ever has any earthquakes. And I've always thought that if we start seeing earthquakes in Africa, then we have come to another level of earthquake activity on Earth. So if Africa starts being shaken, I think the other continents will be shaken even more.
Oh, there's no doubt. I was looking at earthquake activity early this morning. There have been several earthquakes in the upper tiers of Canada, where there's relatively no earthquake activity. There are earthquakes going off in different locations in the United States where there usually isn't any earthquake activity. Very rare is there earthquake activity on the east coast of the United States. They're starting to see, some of that, starting to see even more severe weather patterns that are starting to create themselves in the South Pacific and over near, Indonesia. I think a lot of people are going to be in for a very, very big surprise, within the next 30 to 45 days. As things start to heat up, we start to go through another seasonal change. And I had several people email me and asking me about the Earth tilt, the Earth wobble, and I was listening to Gil Broussard not too long ago, and he said that in their calculations the Earth has an additional 4 degrees of wobble, and that would be definitely something that would create the differences in the jet stream and also our weather patterns. And sure enough, he made these statements back in, I believe it was early December of 2016. And here we are in the beginning of April. We just went through this winter time, and it was definitely a winter that I've never seen in my 49 years of existence on this planet. That much is for sure.
Yes.
But I really appreciate you taking out the time today to go over this report. I've been getting a lot of emails from everyone. They absolutely love your accent. Like I told
Thank
you. You actually got a few marriage proposals. And they love the way that you are able to explain these things in layman's terms, so just the ordinary person can understand all of this. And I appreciate it. I know Chris appreciates it. All of the subscribers and viewers, they all absolutely appreciate what you're doing. And I got a lot of emails that told me to tell you how much respect and admiration that they have for you for, I'll just come out and say it, for being a woman and stepping up, because we have so many of these men that are astronomers, and physicists and scientists, but yet they are too scared, to pull up their britches and step up and be a man and use their knowledge to try to help people. So my hat's off to you also. I thank you very much from the bottom of my heart. And we'll be talking very, very soon once again, and I appreciate the reports. And I'm sure over the next several days, weeks, and months to come, you are probably going to have a hell of a lot more to write about. But if you just give me, I will. You could probably guarantee it, the way things have been going over the course of the last several weeks, absolutely no doubt. But what I'm going to do is I'm going to go ahead and close out our broadcast. And if you could just hang on with me for just a minute, I would greatly appreciate it. And ladies and gentlemen, I would really like to thank all of you for listening in once again with myself, Chris Potter, and our physicist. This is Scott from Planet X News. Thank you for watching. Hello, everybody. Welcome back to Planet X News. This is Scott from the Nibiru channel. I have our physicist with us today, and also we have Chris Potter live here on Planet X News. Chris and the doctor, how are you doing today?
I'm very well, thank you, Scott. And how are you?
I'm doing pretty good. I'm going to keep a little quiet so everyone can hear you speak, because they love your voice and your accent.
Oh, thank you.
And today we're gonna take a look at some more footage, ladies and gentlemen. We were going to be bringing up some more of the SDO footage, and we were going to be taking a look at our sun, but unfortunately, the powers that be do not want us to show you what is currently happening on the sun. As we were trying to get the live stream going, we were not able to link up with the SDO website, which is naturally controlled by NASA and the government. And all of a sudden, the site is down. It almost looks like it has disappeared. So they are probably doctoring some images. They probably have their paint by numbers, little watercolors out with their little paintbrushes, and they are probably doctoring images up as we speak. Now, we've been trying for the last hour to get onto the site so we can bring you this imaging, but they will not let us. And we were going to be reviewing a report that the doctor had submitted to both me and Chris about less than a week ago. And the report was pertaining to why does the sun have so many coronal holes on it. So we're going to be bringing up that report. It's on a PDF file, and we did a report on this a few days ago, and we're going to go ahead and bring this up so everyone can see it. So, doctor, how are you? How's everything going where you live?
Yes, I'm well, thank you.
Well,
Well, yeah, I just have a lot of lecturing to do sometimes, and I'm being busy. But I'm ready to talk to you and
okay, we're going to go
talk
ahead
about
and
what I've written in that article.
Does everybody
Yeah.
see my screen?
Yes, sir. So I wanted to pose a question to the doctor. What is your understanding of what a coronal hole is?
Okay, so a coronal hole is an area in the sun. And you know, the coronal hole is the top part of the sun's atmosphere, and it's the hottest part. And out of it comes the solar wind. So when you get a coronal hole, you get a lower density in certain areas of the corona. So there are less particles. And what happens is it gets darker because of the lower density and the temperature drops. But the reason why the coronal hole itself forms is that the magnetic field lines coming out of the surface of the sun through that area of the coronal hole are seemingly open. They don't curve like they do where there are plasma loops. So they just jut out of the surface of the sun. And when they do that, what's called the coronal hole, that's when the density decreases, and when the fast solar wind comes out of the sun, it actually curves around the magnetic field lines, and out it goes out of the sun. So that drops the temperature and the density, and it looks darker.
That's a dang great explanation. On Wikipedia, just for the listener, it mentions that coronal holes are areas where the sun's corona is colder, hence darker, and has lower density plasma than average because there is a low energy or lower energy in gas levels. Coronal holes are part of the sun's corona and are constantly changing and reshaping because the corona is not uniform. I've only got two more sentences here. The sun contains magnetic fields that arch away from areas in the corona that are very thin due to the lower levels of energy and gas, which cause coronal holes to appear when they do not fall back. Thus, solar particles escape at a rate enough to create a lower density, like you had mentioned, and lower temperature in that area.
Mm-hmm. Yes.
What we're looking at is the document you had put out for March 30th, 2017. What does the sun have so many why does the sun have so many coronal holes? And I've kind of just jumped in here. Can you talk a little bit more about this document and
Yes.
what we're looking at now?
Okay, so the key thing about what I have to say in this document is that there is no such thing as an open field magnetic field line. All magnetic field lines form loops. So the loop, the magnetic field lines that come out of the coronal holes must close and form a loop somewhere. You see the thing to the plasma loop there? That will form a closed loop. It closes inside the sun, and we see there what the part that's outside the sun. And inside the sun, it will close, it will form closed loops. But the ones out of the coronal holes seemingly do not close. And my point is they have to close. They have to close somewhere. So the fact that it looks like they're open means that the sun is connecting to another object that also has a high magnetic field. And then what that does, it causes a particle flux connection between the sun and that object. And it's difficult to draw. That's why I just draw straight lines. The particles actually have a curved path around the field lines, but overall they move away from the sun. But the field lines have to connect to the other object and then come back to the sun to form closed loops. That's the only way. Everybody who has studied magnetic field knows that magnetic field lines have to form closed loops, and this is the key thing here.
So I've noticed, you know, as I've mentioned before, time and time again over the past year, you know, we just keep seeing these coronal holes opening up time and time again, constantly. And I keep repeating and reiterating that there has to be something that is, you know, helping the sun along with these coronal hole openings. And the more and more research that I do, and the more that I read your reports, the reports are, you know, very, very informative. And I've learned a lot from your reports. And you know, I just have to say that, you know, I mean, for me right now, it is beyond a shadow of a doubt that it seems the sun has made some type of, magnetic or electrical portal connection with something, and something is using the sun's energy, and it is just opening up these coronal holes. And what I wanted you to touch on for a lot of the viewers, once again, whenever these coronal holes open up,
yes,
they refer to this as the solar wind, but in actuality, it's really not a wind, is it?
No, it's particles escaping from the sun, because the corona is actually.
Oh,
I think she might have muted herself.
Particle.
there she is.
Oh,
Doctor, are you there, buddy?
Oh.
Oh, yeah, we couldn't hear you for a second. Can you go ahead and repeat yourself? Thank you.
Okay, so when there is a coronal hole, there's a lack of corona there. The density is lower. And when that happens, the solar particles from the surface of the sun are able to escape. And when they escape at high velocity, much higher than the normal solar wind, which originates somewhere in the sun's corona. So this fast solar wind comes from further down, and basically it's a lot of particles leaving the sun that the corona would stop from leaving if it was there. So that's what's happening here. So that's what gives rise to the fast solar wind, and it increases the cosmic radiation coming off the sun, because some of the particles come at extremely high speeds, and to the point that they become relativistic. That is, they get close to the speed of light. And I've written about these particles before, not in this article, but these particles are cosmic radiation, and the Earth does not, the Earth's atmosphere does not actually protect us very well from this cosmic radiation. So these are high energy relativistic particles that hit our atmosphere, and they cause cascades of particles and gamma radiation, and they are harmful to living organisms. They cause mutations and therefore lead to cancer. So that's what's happening when we have large amounts of coronal holes. So the Earth is impacted and affected.
There was something that I wanted you to touch on, and I've had this debate with others over and over and over again, and I've read other scientific papers pertaining to these particles as they stream towards the Earth and they impact the Earth. They have the ability to impact and penetrate all the way to the Earth's core, therefore heating up the Earth's core, and that is the reasoning for all of the increase in earthquake activity. I mean, I've read 2 papers on this, both of them published scientific papers, but yet, there are still the naysayers, and they sit there and they tell you point blank, there is no relation to or from coronal holes to earthquakes. Now, do you find that true, or do you have a difference of opinion?
Well, there's definitely a connection. If anything, I mean, you can think of it as very extremely high energy particles and being able to penetrate into the Earth. I mean, there are particles that are very unreactive, like neutrons and definitely gamma radiation, if it's very high energy, would be able to penetrate. The ionized particles probably would not penetrate that far unless there are the energy